A2 Pure Maths, Chapter 8, Functions and Graphs. First of all, we're going to look at a special function called the modulus function, and then we're going to look at more general functions and what the definition of a function is in mathematics. So first up, section 8.1, the modulus function. The modulus function is a non-negative numerical value. It is sometimes known as the absolute value function, and on a calculator, this is often labelled ABS, short for absolute. If you have a Casio ClassWiz calculator, then it is above the open bracket button. So you'll need to press the Shift key first to activate it. We have used the modulus when finding the scalar value of a vector. That's where the direction is not important. So 2 meters per second and minus 2 meters per second, if they were velocities, they both represent a speed of 2 meters per second. So their velocity is a vector, speed is a scalar. So if we do the modulus, or we do the absolute value of the vector velocity, it gives us the scalar speed. A with the vertical lines around it is the notation we use to represent modulus. So for example, the modulus of 2 is the same as the modulus of minus 2. They both equal 2. Here's how you do it on a calculator. So Shift and then the abs button. You see the vertical lines there. So put a number in such as minus 5. And before you press equals, just think, what answer are you expecting here? Hopefully you expected the number 5. So it just looks at a number and works out how big it is. Doesn't care about whether it's positive or negative. So let's go on to the following example, 8.1.1. Write down the moduli of the following real numbers. Moduli is simply the plural of the word modulus. So when there's more than one, we call them moduli. So part 1, make sure you use the right notation as well. So vertical lines around the minus 2 means we're doing the modulus of minus 2, which is just 2. Part 2, the modulus of the number positive 1. Well, that's just positive 1. Part 3, the modulus of the number 0. Well, that's just 0. So please remember, the modulus of a number is just simply how big is the number. We don't care whether it's positive or negative, just how big is it. How far away from 0 is the number. Now for part 4, I want you to have a go at this one before you see my solution. So write down the modulus of 4 take away 16 take away 12. Pause the video if you need to and have a go. So part 4, the modulus of 4 take away 16 take away 12. Well, 4 take away 16 is minus 12. Take away another 12, that's minus 24. So the modulus of minus 24 is 24. Now there's a common error here which I want to point out so that you don't make it. If we're doing the modulus of 4 take away 16 take away 12 like we did in part 4, we can't do the modulus of 4 take away the modulus of 16 take away the modulus of 12. That gives us the wrong answer. Also, anything like that, such as the modulus of 4 plus the modulus of minus 16, or even plus in the modulus of minus 12, again, that gives us the wrong answer. And if you need convincing, you can always check it on the calculator. The modulus of 4 take away 16 take away 12 is the modulus of minus 24, which is 24. Let's move on to the next example now. F of x is 2 times the modulus of x take away 3, and then after that take away 5. We're going to work out f of 6, f of 3, f of 1, and then f of minus 1. In the box it says the modulus sign acts like a pair of brackets. So it's not exactly the same, but it acts like a pair of brackets. So if you want to, you could rewrite f of x as the modulus of 2x take away 6 take away 5. I mean, there's no need to, but that would be the same as with the 2 in front of the modulus. So please have a go at these before you see the solutions. So pause the video now and have a go. Alright, so I've substituted 6, 3, 1 and then -1 into f. And you can see them there. They just need working out now. So the first one, we have 2 multiplied by the modulus of 6 take away 3. So that's the modulus of 3, which is just 3. So this becomes 6 take 5, which is just 1. In part B, we end up with 2 times the modulus of 0, which is 0, and then take away 5. So a final answer of -5. On part C, we end up with 2 times the modulus of 1 take away 3. In other words, the modulus of -2. And then take away 5. I'm just going to put an extra step in for this one. So 2 times the modulus of -2. Well, the modulus of -2, I hope we know now, is 2. So this is 2 times 2, and then take away 5. So that's -1. On part D, we have 2 times the modulus of -4, and then take away 5. So that's 2 multiplied by 4, then take away 5, which is 3. We're now going to draw the graph of y equals the modulus of x. Well, think about what we've learned so far, and let's work out what this graph will look like. If x is a positive number, then when you do the modulus of that, nothing happens, nothing changes. So let's just write down a few x and y values here. So if x was 2, y is the modulus of 2 in this example. So we're letting y equal the modulus of x. So if x was 2, y is the modulus of 2, which is just 2. If x was 4.7, y is the modulus of 4.7, which is just 4.7. So if x is 12.9, the modulus of that is also 12.9. So in general, if x is more than or equal to 0, then y and x are the same. As we've seen a couple of times already in this chapter, the modulus of 0 is also 0. So if x is more than or equal to 0, then we have simply y is the same as x. So I'm going to draw the first part of the graph where x is bigger than or equal to 0. We get the graph y equals x, which is a straight line with a gradient of 1. Now let's consider negative values of x. If x is -1, y is the modulus of that, which is +1. If x was minus pi, y is the modulus of minus pi, which is pi. If x is minus 13.8, y is positive 13.8. So have a think, what can we write down now in general? In general, if x is negative, then y equals, pause the video and have a think, try and work it out before you see it on the screen. If x is negative, then y is negative x. So looking at the 3 examples I did, let's take the middle one as an example. If x is negative pi, then y, which is the modulus of x in this example, becomes positive pi. It's like timesing the x value by -1. Hence we get y is equal to negative x if x is negative. So now I'm going to draw the remainder of the graph. If x is negative, then we get the graph y equals minus x, which is a line with a gradient of -1. And there we have the graph of y equals the modulus of x. It's like a V sign. Both of these two lines are at 45 degrees to the x-axis. At That's not massively important, but it's worth being aware of. That's 45 degrees to the x-axis, and so is that, which means there's a right angle between them. So there we go. That's the graph of y equals the modulus of x.